All right, we're finishing up here with section 10.2, goodness of fit test, chi-square test. And so what we need to know, I'm going to boil it down to you guys for what you need for your graphing calculator. Your null hypothesis is the population fits the specified distribution of categories. The alternate is that the population has a different distribution. We'll need to be able to find the expected frequency because we have observed and expected, right? So that's just your sample size, your total sample size, times the probability, the percentage, or if it's written decimally, assigned to each category. And the degrees of freedom, you'll need to know that. That's the number of categories minus 1. And you can read the rest of this and look through examples in the text. What we are going to do, my wheel's spinning for some reason. What we are going to do is look at problem number 6 in this textbook, which is on page 644. I assigned you problems 5 and 7 for homework. So census, type of household, the type of household for the US population, and for a random sample, this is your sample size, 411 households from the community of Dove Creek, Montana are shown. So you'll see on the table, you have the type of household going down, married with children, married, no children, and so on. Notice that there's 5 categories. These are the percents of US households, all right? So these are my percentages, my probabilities. And this is the observed number of households in Dove Creek that fall into these particular categories. Use a 5%, that's alpha equals 0.05 level of significance, to test the claim that the distribution of US households fits the Dove Creek distribution. All right. So first of all, here's our observed, this column right here, the 102, 33, 96, and 68 are our observed categories, which is this last column on the table in the textbook, right? We need to calculate the expected, and here's how you do it. For this first category, married with children, we multiply 0.26 times 411. So I only did the first one for you, typed out. 0.26 times 411 is an expected value of 106.86. For the second one, married, no children, 0.29 times 411 gave me 119.19. Third category, 0.09 times 411, 0.09 times 411 gave me the 36.99. For one person, 0.25 times 411 gave me the 102.75. 0.11 times 411 gave me the 45.21. Remember, degrees of freedom is number of categories minus 1. 5 minus 1 is 4. So we need degrees of freedom because we got to type it in when we go into our chi-square test. So here's what we're going to do. We're going to go into stat, edit. Now, I've already entered in list 1 my observed values. And in list 2, these are my expected values that I had to calculate. Okay. So I'm going to do second quit. Then we're going to go into stat tests. We want option D, delta. This time, rather than scroll up or down, where's D? It's above X inverse. I'm just going to do alpha D, or you could scroll up or down. And so the observed is in list 1, the expected is in list 2. If you have a different than that, if it's in a different list, obviously change the list, right? The degrees of freedom for this problem are 4. We'll calculate. Take a look at the p-value, 0.01. Right? That's less than alpha. So for this problem, we would reject the null hypothesis. And we would conclude that the Dove Creek household distribution does not fit, at least based on this data we have, does not fit the general US household distribution. So again, we reject the null hypothesis because your p-value was less than alpha. And again, let me show you the test one more time. It's option D for this section. Oops, I can quit. That. Tests. Try that. Alpha D. We want this chi-squared goodness of fit. That's what the GOF stands for, chi-squared goodness of fit test. And that's what you need to know. Congratulations. This was your last new section.